Basic mixture analysis means it is analysis of two cations from the mixture. When it is two cations from the mixture, what I mean by is that in 11th standard you have done salt analysis where you are detecting a cation and an anion from the mixture. Now this year we are going to have mixture analysis which is basic and acidic. In basic mixture analysis we will be analyzing the mixture and detecting two cations from the mixture, and in the board exam this will be the weightage of this experiment is 10 marks for it. You are going to detect two cations from the given mixture here. First of all, we divide this whole analysis into three parts. The first part we call it as preliminary test, second part is dry test, and third part is wet test. Now the first part, that is preliminary test, we are going to just observe the mixture and write it down. So the color is the first test. So you all can see the color of the mixture. The color of the mixture you can see this is white in color. So you are going to write the observation accordingly. Nature, in your syllabus all the basic mixtures will be crystalline. So that remains a standard observation, crystalline. Now coming to the second part, that is dry test. In the dry test you are going to do the analysis with the dry mixture, and there are 4 tests there, out of which the first test is heating in a dry test tube, second is charcoal cavity test, and these 2 tests you will be writing down the standard observations. For all white mixtures you are going to write the observation white residue, and for all colored mixtures irrespective of the color you are going to report as colored residue. So today the mixture you have seen the color, it is white, and hence you are going to write the observation for heating in a dry test tube and charcoal cavity test. The observation remains as white residue. You will be writing down the corresponding inference referring to your handbook. Now coming to test number 3, that is NaOH test. When you are performing this test, you are checking only for the ammonia smell, because this test is done for only one radical, that is ammonium, and hence you are going to do the test directly with the mixture. You will be taking a test tube. In the test tube you will be taking little bit of the mixture using a spatula. You will have to add dilute sodium hydroxide solution. Now my student is going to add sodium hydroxide solution to the mixture taken in a test tube. Yes. Now shake the test tube and you have to smell the smell of the test tube solution, and as you can see the reaction, and this has a smell of NH3, that is smell of ammonia. So ammonia may be present, and here the observation will be smell of NH3, ammonia may be present. Coming to test number 4, that is a flame test. For performing the flame test, we make a paste of the mixture with a drop of concentrated HCl. So you take a watch glass, in the watch glass you add the mixture, and to the mixture you make a paste with a drop of concentrated HCl. Yes. So the paste is ready. Now we are going to perform the flame test. Is going to light up the burner. Now we have to adjust the flame to oxidizing flame, the blue flame. Now we will take the platinum wire or the platinum loop. We have done this in the last year also, just heat it to check it is clean. Now dip it in the paste. You will heat it in the flame and you will be able to see the color of the flame changing, and the flame changes to crimson red flame. You can see it is little bit different It is a shade of the crimson red. So, the flame has changed from blue flame to crimson red flame. That means the radical which you are having it here is strontium, and hence strontium may be present. So, your observation will be crimson red flame and the radical is strontium may be present. Now, that finishes with the dry test. Now, we are going to proceed with the wet test. So, wet test means you have to prepare the solution. So, we are not going to use the mixture directly. Stir the solution so that you get a clear solution. Now, what you get is a clear solution. Now, this is called as the original solution, and you will be referring to this as OS, that stands for original solution. Now, with this original solution we are going to perform the wet test, and when you are performing the wet test, first comes the analysis of group 0. So, you repeat the test what you have done it in the dry test with the wet test. Now, instead of mixture we are going to take OS. To OS we are going to add NaOH, that is sodium hydroxide again. So, we are repeating the same test what you did it with your dry test. You shake and you get the smell, and you get the smell of ammonia. So, you have smelled ammonia twice now, and that shows group 0 is present. So, let us confirm it. We know as chemistry students we doesn't depend only on the test, we go for the further this, and that is confirmatory test. So, we need to confirm it. So, let us go to the confirmatory test. So, we take a test tube. In the confirmatory test there are two confirmatory tests. We first take Nessler's reagent. The test tube should be cleaned properly, washed properly. To that we add Nessler's reagent. Now, the Nessler's reagent you can just see it is clear, transparent, just show it is a clear transparent solution. Now, to this we are going to add 1 drop, exactly 1 drop of OS. So, we take a glass rod, dip it and then dip it into the solution, and you can see now your clear solution has turned to be brownish. So, you can see the brown precipitate, your solution has turned brown due to the presence of brown PPT, and this brown PPT shows, so ammonium is confirmed. So, your ammonium radical is confirmed by seeing a brown PPT with Nessler's reagent. So, we repeat this with another CT. So, we are continuing to the another CT, we take OS. To OS we add picric acid which is already dissolved in benzene. So, that is picric acid in benzene. So, again your OS is transparent clear solution. To that you add picric acid in benzene. You have to just shake the solution, just jerk it. You can see clearly the yellow PPT, and that shows the another CT for ammonium. So, your ammonium radical is confirmed. So, out of the 2 radicals we are confirmed with 1. So, now we have to focus only on one of them, that is your second radical. For the analyzing the second radical you have to do the detection of the group. So, we go to the first test in the detection of the group. We take the OS. To that we add HCl, that is dilute HCl. You can see a very clear solution. The expected observation is white PPT which is not seen. So, you know that there is no white PPT. So, your group 1 is absent. To the same solution we can continue to the second test. You can add H2S water to it. OS plus dilute HCl, you got a no PPT, so you can continue the same solution to go to the next test, that is you added H2S, expected was a black PPT, and you can see there is no black PPT, the solution is very clear. So, group 2 is absent. So, your group 1 is absent, your group 2 is absent. Now, you go to step number 3, and in the step number 3 you take OS. To that we add equal quantity of ammonium chloride solution. It is ammonium chloride solution. We add that to equal quantity. To this we add ammonium hydroxide. You will use a dropper, and ammonium hydroxide is in an amber colored bottle. You will add it. You can keep your thumb on the top and invert it so that solution OS does not remain unreacted. So, there is a uniform distribution of the reagents, and you can see it is clear, that means there is no PPT. So, group 3 is absent. Now, since group 3 is absent, we go to the next step, that is step 4. To the step 4, you take OS, you take ammonium chloride, equal quantity, you add ammonium hydroxide, you can add the H2S to the same solution, and the expected answer is either white or black PPT. Let us see what is happening. Just invert the test tube so that there is a uniform reaction taking place, and what do you observe is neither a white nor a black, but still clear solution. That means group 4 is absent. Now, we proceed to step 5 of the wet test for cations. In that we take the OS in the test tube. To that we add equal quantity of ammonium chloride, equal quantity of ammonium chloride. Then proceed with ammonium hydroxide dropwise for using a dropper. And the reagent for this group is ammonium carbonate, saturated solution of ammonium carbonate, and just observe what happens. You can clearly see a white PPT. You can clearly see the white PPT, that means group 5 is present. Now, to the entire OS, you will have to add ammonium chloride followed by ammonium hydroxide and then the group reagent, that is ammonium carbonate, by which you got the white PPT. So, you have to add that to the entire OS. So, the same reagents with which you got the white PPT, you are adding, repeating with the entire OS. So, you get the white precipitate of group 5. Now, we need to centrifuge this, that means separation of the PPT from the entire solution. So, we take a centrifuging tube. The centrifuging tube is slightly narrower at the base, it is not exactly a test tube, it is a different type of test tube in which the base is narrow, and this has to be balanced in the centrifuging machine. So, you will transfer that the PPT, shake the beaker and transfer the PPT into the centrifuge tube. We need to balance the centrifuging machine with 2 centrifuge tube. So, we take equal quantity of water in another centrifuge tube. So, now we have 2 centrifuge tubes. In one we have white PPT of group 5 and in the other we have equal quantity of water, and this has to be centrifuged to separate the PPT of group 5 from the entire solution. Centrifuging is a method by which you separate the PPT from the entire solution. Now what you can see is the centrifuging machine which has got two arms. The two arms has to be inserted with the two centrifuge tubes. The two centrifuge tubes, in one of which is the white PPT and the other one is a transparent solution, that is your water which you have taken, and you are going to start the centrifuge process. Now this, when it is going on, what is happening is the separation of the PPT entirely from the whole solution. Now you will be able to see clearly the precipitate separated from the whole entire solution. You can see it very clearly, the white PPT which is clearly separated out, it is there at the base of the centrifuge tube. Now we have to make a clear solution. You have the solid precipitate which you can just throw away the solution, that is what is called as the centrifugate, which we throw it out, reject it. Now we have left with only the precipitate. For group 5, the agent which is required, the reagent which is required to dissolve the PPT is acetic acid. So we have to warm the acetic acid a little. We are going to dissolve the PPT in hot acetic acid. So now acetic acid has to be heated and we are going to add the hot acetic acid to our centrifuge tube which already contains your white PPT at the bottom of the centrifuge tube. You do not have to boil the solution, just warm a little. So this warm, the hot acetic acid, we are going to pour to the white PPT in the centrifuge tube. So so you will be adding this hot acetic acid to white PPT in the centrifuge tube. Just jerk it and you will see the carbonate, because I told you it is the carbonate of the group 5. So you will be able to see the effervescence which is been released. So once it becomes transparent, you are ready to do the analysis of that particular group. In this case, we are going to do the analysis of group 5. So now we are going to proceed to the analysis of group 5. We have a transparent TS. As you can see, it was a white PPT earlier. Now we got a clear transparent solution, just similar to your OS. First test that you take is TS. This solution we call it as a test solution, that is the TS. To that we add potassium chromate. We are going to add potassium chromate. Potassium chromate is already a yellow colored solution. So we are going to add to that. We are going to add potassium chromate to it. Potassium chromate is already yellow in color. So our solution still remains yellow color, no yellow PPT. So I will say it is no PPT. So it is taking the color of the potassium chromate. So there is no PPT. So your option will be calcium or strontium present. Now out of calcium or strontium we want to find out which one of them. So we go to the next test, that is we take TS. We have to do all the analysis, further analysis with the TS. So we take TS, to that we add ammonium sulphate. Now this will give us a hint whether we have calcium or we have strontium. So we have ammonium sulphate. Now let us check what is happening. Now you can see very clearly white PPT. So what you see is white PPT. So your observation of white PPT with this test, that means strontium is present. So now we got the second radical, strontium. So we still, as I told you, we will be continuing with the CT, that is a confirmatory test. So we are going to do with the confirmatory test of strontium. So we have two confirmatory tests, out of which the first one is TS. To the TS we add dilute sulfuric acid. To TS we add dilute sulfuric acid, and we are predicting a white PPT because we have seen strontium present, yes, and we got white PPT. So, here now we see white PPT, so strontium is confirmed. But we still continue with one more CT and check whether strontium is confirmed. So, we go to this last test, that is the second CT of strontium, that is TS. To TS we add ammonium oxalate. To TS we add ammonium oxalate solution, and we are getting the white PPT. So, here strontium confirmed again. So, the two radicals that we got from the basic mixture analysis, that the two radicals were unknown, and so finally we got two radicals. The first one was ammonium and the second one was strontium. So, the two radicals which we detected with the CTs, and that finishes with the basic mixture analysis. I remind you once again, the weightage of this experiment is 10 marks for the board exam. Okay? Thank you.